Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Azhar Adilambi Indra, and as a group leader for this project, group project, I will introduce my group member. With me, I have Anis Amira binti Haris and Fadila binti Nasir. And today we present you about our group project. So let's start.
Assalamualaikum and good day to Dr. SUHAILA. I am Anis Amira binti Haris and I will be presenting the introduction and the data preparation, cleaning and wrangling for our group, for my group. So this is our raw data that we get from kaggle.com and we have 14 columns. The data is basically about the rank of the university around the world, which rank from rank 1 to hundreds. So here you can see there are rows with dash value, there are a weird format column, and so on. So that's all for the intro, and then next is for the data cleaning. So this is our Python file. At first it was saved as data frame and it's saved as data. So from what we can see here is that there are 2,603 rows of data, including the header, and there are 14 columns. So firstly for the data cleaning, as you can see from the data frame dataset, there are university with rank in range, such as this one, which range from 601 and 800, and there are no. So we can say that there are no valid value for them as they are in range. So we choose to drop down the rows with their work rank as put in range, such as 201 to 225, 201 to 250, and so on. And then we are left with the data of university rank from 1 to around 200 only for each year. Then for the next is we check for any null value in the data set, and there are null values in students, student staff ratio, international students, and female-male ratio column. And then for the data type, we can see here that there are columns with numerical value, but it was read as object in the Python. So we want to change it to either float or integer as to ease our work during our data visualization. So we take the column which we are sure that they are numerical value, and change the type to either float or integer. As you can see, the income, international, students, total score, and work rank, their type are changed, and there are also null value in them, and so that's why we fill the empty value with 0, or change the dash with 0. And then after that we do the d types. Here we can see that their data types are changed to float and integer instead of object. And then for the next one, we miss a column, and so international students column are also changed to float type. And then we also wrote female-male ratio column, as it will not be used further in our Python project. And then for the data wrangling, we want to see the rank based on year and country, and We set the index as year and country, and here we can see that from before the year is uh, at the end of the table, and then it was moved, and it has it will make it easier for us to see the rank based on the year of each rank instead of going to the end of the table just to see it. And we can also see based on the country of each university. And then for the next data wrangling, we swap the level of the index to so country become the first one and year become the secondary. So here we can see that Australia country is the first country, and then during the year 2011, their Australia's top university are ranked 36 in the world, and it is University of Melbourne. So it was also arranged in world rank, but it was based on the country. So the first world rank must be somewhere in the under the country. So that's all from me. The next part will be presented by Fadila. Thank you.
Assalamualaikum, my name is Fadila and I will continue the presentation. So I will present about data grouping and aggregation. So the first part is I do data grouping by year and university name, and then I find the average of the score, assessment score for teaching, international research, citation and income for each of university by year. And the output will be like this. I will show the average score for each assessment. And then next, I do a group by year and country to find the total number of university in each country. The output will be like this. It will show the year, country and total of university for each country. The third one is find the minimum and maximum of number of students, international students, student staff ratio, which I group by year. So here you can see six different years from 2011 and to 2016, and then the number of students from minimum, which is 0, and the maximum is the highest number. Same goes to international and student staff ratio. And then the fourth one is I do a group by function for aggregate sum for total number of students, where I group by a year and the country. And the third output will be turned out like this. It will show the sum of number of students. For this include all university that in Australia for 2011. Okay, next I will go to data visualization. So this is the coding for this first part. First graph that we created, we create top 10 university assessment score in 6 years, 2011 to 2016. So for the analysis, as we can see here, we create a different line for different assessment score. For the analysis for this chart, as we can see, we create different line, marker, and color for different assessment score. Uh, International income research, teaching and citation have different. It's come from different column. So we should differentiate it so we can see it clearly lah. Okay, and for the and then as we see here, the higher the score for the higher the assessment score, the higher the university will be in the wood rank. So the university depends on the score to be top in the wood rank university. Okay. Okay, for the second chart, we use bar chart for number of university in each country that got into top 200 for 6 years, 2011 until 2016. Okay, so from all these bar chart, we can see that United States of America have the most number of universities that got into World University rank. So we also can conclude that the university in United States of America has top the top among others country. Okay, for each bar chart, we can see we use different colors for different country, so we can easily differentiate since the country have then more than 10 countries, so we add a color list at the top of the coding here. Okay, so that's all for the bar chart. And the third one is we create a pie chart where we create the percentage of total number of university in China that inside the world rank universities. So from the pie chart here, we can see that in 2011, the university that they have the most university that inside the world rank universities, while 2013 and 14 has 2013, 14 and 16 has the least percentage. So from this chart encoding, we also group by the university by the year, so you can see it differentiate each of the category by year: 2011, 12, 13, 14, 15 and 16. Okay, so that's all for the data visualization. Thank you.
Okay, next I will present about machine learning. For machine learning, we decide to propose two type of machine learning. First is linear regression, and another one is multivariable linear regression. Basically, it is a simple linear regression, but we implement two type of data. So for the first linear regression, we use filter 2016. which is this data we have grouped it here. We fill 2016 data about university. The data university in 2016. So basically, we will predict. First, we will predict about uh, the 2017 university ranking according to the total score that we assume the university will get. So, so here we use word rank and total score column. Here we plot the scatter plot using word rank and total score, and after that we from the data set we generate training and testing data set, which is train data we will use uh, to predict the value, and to check accuracy of the predicted value we use test data. So here we use modeling so that the training set data will fit to our model data, which is linear regression. We use import this linear model from sklearn. Actually, we have import this at the top of the coding here, so we repeated it back. We code it back here, and here we will get our coefficient value and intercept value. This coefficient value and intercept value will be used to plot the regression line here. We plot the regression line using our train set data. So here the graph. So here next we done our prediction. We will which is we want to predict the university ranking if the total score for the university is like this. Uh, so we use a regression prediction function to predict our value. So here we assume that if the total score of the university is 87, so here the calculation been made, not the calculation lah, but the function being implement. So here the total score, regression intercept, regression coefficient. So estimated. So we got 63 estimated ranking. If the university got 87 in total score, they will be they will get ranking 64 after we run off. They get 64 ranking. But when we check the accuracy, we import sklearn.matrix, which is we using it r square score, r squared formula. So using the predicted value, we calculate the absolute error for the prediction and sum of square error and the r squared score for the prediction value. As the value shown, we can conclude that the predicted value is not very accurate, not accurate at all, because as we can see, the R2 score is far from near to 1, and as we can see if we look at the absolute error value and sum of square error value, it is far from each other. That's why we conclude that the predicted value is not accurate. So next is we use multivariable linear regression. Here we want to know uh, is at the assessment score, is it influence or effect, give significant effect to the total score. So here we take teaching, international, income, research and citation column, and SY data is total score. Our output value is total score. So here from the data set, we we generate training and testing data, which is 18% from the data we use for training. So we feed it with our model, linear regression. And here, as we can see, we train the data. After that, we calculate the coefficient value and print it in using data frame. As you can see, the coefficient value uh, the value is small. The value is small. So we conclude that we assume that the all of teaching, international, income, research, citation influence or give most significant uh, most significant effect to the total score. So after so that we make prediction according to the value, coefficient value. And here prediction, the prediction will predict uh, the score, the assessment score for each assessment, for each university, for each year actually. So after we check the accuracy using R squared formula, we got 0.99999, which means it is near to 1, and we conclude that the predicted value is accurate. So that's all from me. Thank you.